Section 9.9 is just a quick introduction to trigonometry. We'll be dealing with three of the main trig functions, which are sine, cosine, and tangent. And what you'll notice on the screen right here is you see the Greek variable theta. And it shouldn't really throw you off. Most trig equations and trig problems, they use Greek letters. So theta is just basically a variable, as would x or any other variable that we'd used previously. So what sine would be is it is the ratio of opposite side over the hypotenuse, whereas cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. You may be familiar with the saying SOHCAHTOA. That's just an acronym to kind of help you figure it out. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Now, when you go to calculate these ratios of the trig functions, you look at where the variable is. So in this case, it's over here. And we'll label these as A, B, C for the vertices. The opposite, as you can guess, is over here. Adjacent basically just means what's attached to it, so this is the adjacent. And the hypotenuse, as we've always talked about, is opposite the 90-degree angle. Now, usually when you're talking about trig functions or trig diagrams, your angles are always going to be capital letters, and the sides will be lowercase. So if this would be angle A right here, this would be side A. It's opposite, again, the angle. So if the 90-degree angle is B, the hypotenuse would be labeled as side B. And if angle C is over here, side C would be over there. What we're just going to do in this example is we're going to be looking at the following diagram, and we're going to find the following trig functions from the following angles. We'll find tangent of angle A, cosine of angle A, and finally sine of angle B. Again, when you're looking at these, it's important to figure out what angle you're actually using as a perspective. So for the first one, tangent of angle A, we're up here. And tangent is opposite over adjacent. So from angle A, opposite would be side A, and adjacent would be 11.6. Here's opposite and adjacent. So the ratio for tangent angle A would be 9 over 11.6. Now cosine of angle A. Again, we're looking from angle A, and cosine is adjacent over hypotenuse. So the adjacent would be 11.6. Your hypotenuse would be 14.7. So cosine angle A would be 11.6 or 14.7. And finally, we're going to do sine of angle B. This time we're going to be looking from this angle, and we want sine of angle B. And sine is opposite over hypotenuse. So in this case, opposite of angle B would be 11.6, and hypotenuse is 14.7. So it would be 11.6 over 14.7. And what you should hopefully notice is that the last two that we did are exactly the same ratios. And that's not a coincidence. It always happens. The cosine of one of angle that's not a right angle will be the same as sine of the other angle. What we're also going to use these trig functions is to actually find lengths of side. And we'll be using our calculators to do this. One thing you'll want to do, because we are working with degrees, is go to your calculator and make sure that you go to mode and make sure that degrees is highlighted, not radians. Radians will be used in a different time, but this time we want to make sure your calculator is in degrees. So, how are we going to solve this problem? We want to know what side x is to the nearest tenth. So again, we talked about earlier that opposite sides from the angle, so side x is over here. Now, based on just the information that we have, what you should see is that we're given 37, and the relationship between angle 37 and x is that this is the adjacent, and that the 11 is the hypotenuse. And what you want to think of is what trig function uses adjacent and hypotenuse. And hopefully, you've come up with a conclusion that's cosine. Well, it's cosine of the angle, which is cosine of angle 37, and that ratio is x over 11, or adjacent over hypotenuse. And what you're going to do is you're just going to use your calculator and your algebra skills to figure out what x is. You'll multiply both sides by x. Multiply both sides by 11 to cancel out the 11. And you'll get x equals 11 times cosine 37 degrees. If you put that in your calculator, you'll find that is 8.8 approximately. Now, here's something that you'll need to know or want to know for future problems. You don't have to use cosine 37. What you could also do is you know that because this angle is 37 and this angle is 90 degrees, that angle x has to be 53 degrees. And then what you can do is you can figure out the perspective from angle 53 degrees. You can say that x is the opposite, while 11 is the hypotenuse. And what uses opposite and hypotenuse? It's sine. So you do sine from the angle, which is 53 degrees, equals x over 11, multiply by 11. Again, using your calculator, you'll get the same answer. Now, you can use either one of those, but a couple of things to make sure of. You cannot use the right angle in the problem, and you want to make sure that you at least use one number. Because if you use this side over here, it doesn't have a number, and if we try to work with that, we'd be dealing with another variable, y, and then we wouldn't be able to solve. Alright, in the final problem that we're going to be looking at today, we're given the following diagram, K-I-T-E, knowing that it's a kite, with sides marked as they are in the diagram. And what we're trying to find is tangent of angle KEI. So KEI is over here. Now, what you'll notice about that is that we don't have enough sides. We at least need two to figure out what the angle is, or the ratio is, from the triangle. But we do know that we have some congruencies, and we do know that in a kite, we have a perpendicular bisector. Now, we don't have quite enough information to find the triangle KEP, but knowing that we have congruencies over here, we'll be able to find out those sides. So, if we look at that triangle, the little left side, KIP, and we know that this is congruent to this, and this has a side or length of 6. That's an isosceles right triangle. And if you remember back to the ratios, we know that the hypotenuse is equal to x square root of 2. So if we solve for x, and we reduce, x is 3 square root of 2. So that will go here, and it will go here. Now we have 2 out of the 3 sides from that triangle, and we can use the Pythagorean theorem to find that missing side. So we'll do 3 square root of 2 squared plus PE squared equals 7 squared. 18 plus PE squared equals 49. Then PE squared equals 31. So PE equals square root of 31. And remember, we're trying to find the tangent of KEI. So from this angle here, the tangent is opposite over adjacent. So the tangent of angle KEI is 3 square root of 2 over square root of 31. And if we rationalize, that's 3 square root of 62 over 31.